Far beyond the stars we see, over 13 billion light-years away, the James Webb Space Telescope is showing us the universe as it looked near its very beginning. For the first time in human history, we can witness the birth of the first galaxies and the first stars that formed after the Big Bang. But what Webb is revealing isn't just fascinating. It's transforming everything scientists thought they knew about how the cosmos really works. For decades, astronomers believed they had a solid understanding of the universe's origin. The story seemed simple and logical. After the Big Bang, the young universe was filled almost entirely with hydrogen and helium gas. Over time, gravity gathered this gas into small clouds, which collapsed to form the first stars. These stars grouped together into tiny galaxies, which slowly merged and grew into the massive ones we see today. Black holes, the mysterious giants at the centers of galaxies, were believed to form much later, after generations of stars had lived and died. It was a neat and elegant story, but Webb's powerful vision has shown us something completely different. The first shock came when Webb began measuring how fast the universe is expanding. For years, scientists have struggled with something known as the Hubble tension, a puzzling disagreement between two ways of measuring cosmic expansion. When astronomers looked at nearby stars and supernovae, they got one answer. When they measured radiation left over from the early universe, the afterglow of the Big Bang, they got another. Both seemed accurate, but the numbers didn't match. Webb's ultra-precise data was supposed to solve this mystery once and for all. Instead, it made it worse. Webb confirmed that the two measurements truly do not agree. It's as if the universe is expanding at two different speeds, depending on how and where you look. This isn't just a math issue. It could mean that something is fundamentally missing from our understanding of the cosmos. Maybe dark energy, the mysterious force pushing galaxies apart, behaves in ways we don't yet comprehend. Or maybe our entire model of the universe, our equations, our constants, even our sense of time and matter, needs to be rewritten. And that was only the beginning. When Webb took its first deep images of the early universe, scientists expected to see small, dim galaxies, tiny building blocks of the massive galaxies we know today. But instead, Webb revealed something no one had predicted. Huge, mature galaxies already formed when the universe was only a few 100 million years old. Some of these galaxies are as massive as the Milky Way, which means they contain billions, even hundreds of billions, of stars that somehow formed incredibly fast. According to every current model of physics, this should be impossible. The early universe simply shouldn't have had enough time or material to create galaxies this big. These galaxies have been nicknamed universe breakers, because they literally break our understanding of how galaxies form and grow. But galaxies weren't the only shock. Webb also discovered supermassive black holes, millions or even billions of times heavier than our Sun, existing when the universe was less than 1 billion years old. According to the old model, black holes were supposed to appear much later after stars had lived, exploded, and collapsed. Yet Webb's data shows they were already there, fully formed and enormous. So how did they grow so quickly? Some scientists now think that these ancient giants may have formed directly from collapsing clouds of gas, skipping the usual step of star formation altogether. Others suggest that primordial black holes could have been born in the chaotic first moments after the Big Bang, making them some of the oldest structures in existence. And Webb's discoveries don't stop at galaxies and black holes. In the Orion Nebula, Webb found something completely unexpected. Hundreds of rogue planets drifting freely through space, not orbiting any star. Even more astonishing, many of these planets exist in pairs, orbiting one another as they travel through the darkness together. This is deeply puzzling because, according to everything we know, planets form in disks of gas and dust around stars. So, how could there be so many worlds floating alone? And how did they form pairs? One idea is that they were once part of star systems, but were violently ejected through gravitational interactions. Another theory suggests they may have formed directly from gas clouds, the same way stars do, but never grew large enough to ignite. Adding to the mystery, some of these free-floating planets give off radio signals that scientists can't yet explain. These signals may come from powerful magnetic fields generated by the planets as they orbit each other, like colossal cosmic dynamos drifting through space. Even the worlds that orbit stars are behaving in ways no one expected. In one young planetary system, Webb found a massive disk of material where rocky planets were supposed to be forming. But instead of being rich in water, the ingredient thought to be essential for life, it was filled almost entirely with carbon dioxide. That means these planets will form with completely different chemistries from Earth, challenging the long-held idea that water is universal in planet formation. And then, there's the world known as 55 Cancri E, one of the most extreme planets ever observed. It's so close to its star that its surface literally glows with heat, hot enough to melt rock. Logically, such a planet should have lost its atmosphere long ago. Yet Webb detected gases swirling around it, moving from its blazing day side to its cooler night side. Somehow this molten planet is holding on to an atmosphere, defying everything scientists thought possible. Piece by piece, Webb is revealing a universe that is wild, unpredictable, and endlessly strange. The expansion of space doesn't fit our models. Galaxies grew faster than we thought. Black holes appeared too soon. Planets form in unexpected ways. And the laws we thought governed everything, time, gravity, matter, are being challenged at every turn. But that's the beauty of it. Webb hasn't solved the mysteries of the universe. It's exposing them. It reminds us that the cosmos isn't a calm, orderly place following perfect rules. It's a vast, dynamic, and creative realm where nature constantly surprises us. And Webb's journey is only beginning. Every image, every new spectrum, every faint glow it detects is another clue in the greatest mystery of all, how everything came to be. The telescope is still in its early years of exploration, but already it's forcing us to rethink not just the history of the universe, but the very nature of reality itself. The deeper Webb looks, the more it shows us that the early universe wasn't quiet or peaceful. It was wild, fast-moving, and filled with chaos and creation. It was a place where galaxies crashed together, where black holes grew at impossible speeds, where stars were born in violent bursts of light, and where entire worlds formed in conditions unlike anything we've ever imagined. The James Webb Space Telescope hasn't just given us new images, it has given us a new perspective. It's showing us that we've only begun to understand the cosmos, and that the real universe is far stranger, faster, and more beautiful than any story we've told so far.